Imagine you are far off the grid, miles from any landmark, when your GPS receiver suddenly loses its signal. The satellite networks powering our modern world are highly precise but fragile, requiring constant connectivity and functioning electronics to tell you where you are. But the night sky offers a permanent backup system. Within the next 6 minutes, you will learn how to read the stars to determine all 4 cardinal directions and calculate your exact latitude. You don't need complex mathematics to do this. You only need a clear night sky, an unobstructed view of the horizon, 2 simple sticks, and a basic tool to measure angles. By relying on the predictable geometry of the cosmos, you secure a permanent method of navigation that functions independently of any digital network. Finding your bearings in the Northern Hemisphere begins with locating the most recognizable pattern in the sky, the Big Dipper. Look at the ladle-like shape and focus on the 2 stars forming the outer edge of the bowl. These are Merak and Dubhe, the pointer stars. Draw an imaginary line connecting Merak to Dubhe, multiplying that distance by 5 to reach Polaris. To measure this, hold your arm out, making a hang loose sign. The distance from thumb to pinky covers exactly the gap to Polaris. Once you have located Polaris, simply drop a perfectly vertical line from the star straight down to the horizon. That point is true north. Because Polaris aligns almost perfectly with the Earth's rotational axis, it provides true geographic north, eliminating the declination errors that can throw a magnetic compass off course. In the Southern Hemisphere, Polaris is hidden beneath the curve of the Earth. Without a pole star to guide them, navigators use a specific set of intersecting constellations. Your primary anchor is the Southern Cross, or crux. You must verify its shape carefully. A slightly larger nearby cluster known as the false cross often leads beginners astray. You can confirm the true Southern Cross by locating the 2 bright pointer stars, Alpha and Beta Centauri, which sit nearby. To find south, project a long, imaginary line straight down through the main vertical axis of the cross. Next, draw a second line that exactly bisects the 2 pointer stars. Where this line intersects your first line is the south celestial pole. True south is the point on the horizon directly beneath this intersecting target point. This basic triangulation transforms a rotating field of stars into a precise fixed compass point. Even if heavy clouds obscure the major constellations, you can still find your way as long as a single bright star is visible. Drive a tall stick into the ground at eye level. Plant a shorter stick in front of it so the tips of both sticks line up perfectly with that star, creating a rudimentary sight. Sit perfectly still for 15 minutes. As the Earth rotates, the star will slowly drift away from the precise alignment of your wooden sticks. The direction of that drift is your key. If the star moves up, you are facing east. If it sinks, you are facing west. If it moves to your left, you are facing north. If it moves to the right, you are facing south. This method works with any star. The physical rotation of the Earth itself acts as a mechanical compass. Establishing direction is only half of navigation. To pinpoint your location, you must calculate your latitude. The angle between the horizon and the North Star is exactly equal to your northern latitude. You can estimate this by holding your arms straight out and stacking your fists. Each fist stacked hand over hand from the horizon up to the star represents roughly 10 degrees. For a more accurate reading, you can aim a simple protractor at the star and use a weighted plumb line. Subtract the reading from 90 degrees to find your latitude. This concept birthed the marine sextant. Its double reflecting mirrors and precision scale allow navigators to measure celestial angles within a fraction of a degree. Measuring this single angle translates the vertical position of a star into a horizontal coordinate on the Earth. You now have the skills to deduce true north, south, east, and west, along with your exact latitude, using only your environment. While digital devices rely on batteries and external signals, the mechanics of the stars are constant and fail-proof. On the next clear night, step outside. Practice finding your pole star and calculating your latitude before you ever find yourself in an emergency. True self-reliance is not about the device in your pocket. It is about understanding your physical place within the mechanics of the universe.